So dear student, I Rakesh Jain from Jamia University. Today I am going to teach you about the natural and artificial radioactivity. We will see certain nuclear reactions which will also include some chain reactions to understand this. So after the completion of this lecture, you will be able to understand what is the meaning of natural radioactivity, what is the meaning of artificial radioactivity, what are the basic differences, what is the meaning of spontaneous effect and non-spontaneous effect in terms of radioactivity. You will be able to understand that due to the fission process occurs in nuclear physics, nuclear science, how an atom will be further divided, a continuous process will be happens of division into subparts. So that is known as chain reaction. So let's start. First of all, just see this MS Paint file where we will start our lecture. Yes. So I just mentioned first of all today date. So today is 6. So see, first of all, I just write down the name of our topic, and our topic is natural and artificial radioactivity. Natural and artificial radioactivity. So, first of all, what is the meaning of this? Natural, as the name implies, a radioactivity process. Radioactivity means what? Whenever a nucleus disintegrate, that is a process of, and some particles will be emitted, like alpha, beta, gamma particles, or some neutrons or protons emitted. So, this process of disintegration of a nucleus of any atom is known as radioactivity. Actually, this radioactivity, it means the nucleus of any atom, whenever disintegrate and emit some particles or parts, that is known as radioactivity. This radioactivity are of two types. One is natural radioactivity and the second one is artificial radioactivity. Natural radioactivity, as the name implies, it is a natural process. It means the nucleus will be disintegrate into subparts or disintegrate. The nucleus disintegration happens due to self disintegration. Artificial radioactivity, as the name implies, in this case, the nucleus of any atom disintegrate by an induced process. By an induced process, it is not natural. In case of natural radioactivity, as a process of disintegration of the nucleus, alpha, beta, and gamma particles will be emitted. But in case of artificial radioactivity, because it is an induced process, as a result, due to the integration of nucleus of any atom, neutrons and protons will be emitted. So, what we understand that natural radioactivity is a spontaneous process. At the same time, at any time, it can happen. We cannot control this process. It is an uncontrollable process. But artificial radioactivity is not a spontaneous process. It is an induced process. That's why it can be controlled. It can be controlled. This natural radioactivity exhibit by elements uh, with atomic number more than 83, and this artificial radioactivity process exhibits by atomic number more than, sorry, less than 83. Generally, the process of this natural radioactivity occurs in three kind of series: uranium series, thorium series, actinium series. Okay, because those are self disintegrate type. Those consist self disintegrate type atoms. So what I want to say, first of all, I just write down, then we will see the basic difference. So natural radioactivity is a spontaneous process in which nucleus of an atom disintegrate the nucleus of an atom self-disintegrate, and as a result, alpha, beta, just to type the abbreviation also. So alpha can be looks like this one. This is the basic symbol of alpha. Alpha. Beta. So beta looks like this one. As a result of that process, some alpha, beta, and gamma. Gamma's abbreviation is like this one. The particles will be emitted. So what I write down, what is in front of you, that natural radioactivity is a spontaneous process, right? Spontaneous means it can happen anytime, right? And so on the spot we can say. So natural radioactivity is a spontaneous process in which nucleus of an atom disintegrate by the self process, means self disintegration happens, and as a result alpha, beta, and gamma particles will be emitted. Generally, this process is not controllable. This is uncontrollable process, because self disintegration happens. That's why it is uncontrollable. This is an uncontrollable process. This is an uncontrollable process, right? Generally exhibits by elements whose atomic number is less than 83, whose more than 83, whose atomic So during the time of chain reactions, that includes that will be related with the nuclear fission process. In chain reaction terms, the uranium will be self-disintegrate. I will show you with reactions. So that is a kind of natural radioactivity. That is a kind of natural radioactivity. And because neutrons and protons will be emitted when further divided into barium and krypton, so that is a artificial radioactivity. So we will see later on. First of all, what is a natural radioactivity? The basic kind of definition, the basic terms related with the natural radioactivity is in front of you. That the natural radioactivity is a spontaneous process in which nucleus of an atom self-disintegrate. This is a very important term related with the natural radioactivity, the self-disintegration. Right? And as a result, and some particles will be emitted due to this disintegration. They are alpha, beta, and gamma. It is an uncontrollable process and generally executed by elements with atomic number more than 83. Okay? And what is the artificial radioactivity? Now see what is the meaning of this artificial radioactivity. Artificial radioactivity is not a spontaneous process, it is an induced process. The artificial radioactivity is an induced process. And one more thing related with the natural radioactivity is that three kind of series generally related with the natural radioactivity, like the uranium, actinium, and thorium. I just write down this thing also in case of natural radioactivity. With the blue color, I just circled this. Three series related with natural radioactivity. That is uranium, that is uranium, tritium, sorry, actinium and thorium. Thorium, actinium, and uranium. These are those three series which are generally related with the self-disintegration process of the nucleus. That's why natural radioactivity process. So now, artificial radioactivity is what? If you talk about the artificial radioactivity, it is not an induced. It is an induced process. It is an induced process. It is not a spontaneous process. Okay? It is an induced process actually, in which nucleus of a atoms disintegrate by induced thing. Disintegrated by induced thing. So emission of radioactivity is due to disintegration of a nucleus through induced process. Okay? The artificial radioactivity is an induced process in which emission of radioactivity, wait, I just write down it clearly then. So the artificial radioactivity is an induced process in which emission of radioactivity is due to the emission of radioactivity is due to disintegration of nucleus. It's due to disintegration of a nucleus of an atom, in which disintegration, in which nucleus of the atom self disintegrate. But here, due to the disintegration of nucleus of any atom by induced process. Okay. So the artificial radioactivity is an induced process because the emission of the radioactivity is due to, or we can say the disintegration of a nucleus is due to an induced process, right? Here, protons and neutrons are emitted due to this process. Here, due to this process, protons and neutrons will emit. In the case of natural radioactivity, we saw that alpha, beta, and gamma particles were emitted, but in this case, the protons and neutrons will emit it. Because this is an induced process, that's why it is a controllable process. It is controllable process, right? And generally exhibits by elements whose atomic number is less than 8. Generally exhibited by elements whose atomic number less than. So that is the meaning of natural and radioactivity. But the most frequently asked question related with the natural and artificial radioactivity in subjective papers are give the difference between the natural and artificial radioactivity. So whatever we studied till now, we just put those things in a tabular manner, so we will understand the basic difference between natural and artificial radioactivity. So I just save this file and we just open. Wait for me. I just save this file as natural and artificial. So, okay. See the next slide. So what is the difference between a natural and if we talk about what is the difference between natural and artificial radioactivity, then we should give the answer in terms of tabular manner. In examination it will comes in front of you. So just to see the differences are same which we studied till now, but we have to see once again them in tabular manner, so you will be easily understand how to write the answer of those particular kind of questions. So natural radioactivity, it's written on this side, and for the artificial radioactivity, let's write down. See the basic difference between a natural radioactivity and artificial radioactivity. It is very simple now. So the first difference is, I just write down in a short manner. So emission of radioactivity is due to the emission of radioactivity is due to self disintegration of nucleus. Okay, the same thing which I told you. Now, what is artificial radioactivity? So here the emission of radioactivity is due to the emission of radioactivity is due to disintegration of nucleus. Okay. The emission of radioactivity is due to induced disintegration of nucleus. Okay. So this is a very first difference between the natural radioactivity and artificial radioactivity. The same differences I am explaining so that you will understand how to write the. This is a spontaneous process, right? But this is artificial radioactivity is an induced process because this is artificial. The third difference is because this is spontaneous, so it is uncontrollable process. But this artificial radioactivity is a controllable process. This occurs when on those atoms which has atomic number less than 83, as I have already been taught. These differences in first file which is in front of you. As a result, alpha, beta and gamma particles will be emitted, but here neutrons and protons are emitted. Exhibit by elements whose atomic number is less than 83, but their atomic exhibits in case of natural radioactivity exhibits by element whose atomic number is more than 83. Just right here. Here also the same difference. Exhibits by elements whose atomic number is more than. So this natural radioactivity is actually exhibited by those in which the atomic number is more than 83. But here we can say in case of natural radioactivity, sorry, artificial radioactivity, it exhibit by elements whose atomic number is less than 83. Whose atomic number is less than 83. Whose atomic number is, instead of more, I should write down less. This is your fourth difference, and the last difference is about what kind of particles they emit. So alpha, beta, and gamma particles emit. So I just write down it's alpha, beta, and gamma. So I just write down the abbreviation for those instead of full name. So it emits alpha, it emits beta, and it emits the third one as. And here in the case of artificial radioactivity, it emits neutrons and protons. It emits neutrons and protons instead of those alpha, beta, and gamma particles. Apart from this, in case of artificial radioactivity, we can say whenever the uranium, we have already been seen one example in case of nuclear fission that whenever nuclear 235, that is a heavy isotopes of an atom, when collide with the uranium neutrons, then uranium further the process will be happens, and as a result uranium 236 will emit, which further split into barium and krypton, and neutrons will be emitted. So that is a process in which heavy isotopes of an atom, that is uranium 235, when collide with that neutrons, then neutrons will be emitted further. So that is also an example of that radioactivity process. So these are basic difference between natural and radioactivity. Now we will see the nuclear chain reactions, or we can say chain reactions, nuclear reactions, chain reactions. So let's see. First of all, I am talking about the nuclear reactions. So we have already been seen in case of nuclear fission and fusion examples, like whenever, let's suppose this is your uranium, this is your uranium 235. Okay. Whenever this uranium, that is a heavy isotope of an atom, whenever neutrons will be collide with that high speed neutrons, when collide with this uranium 235, then what will happen? I can represent this neutron by n single n, so you understand that this is not, I am not talking about any atom or any periodic number component, I am just talking about neutrons, so don't be confused. So as a result, it will be into neutrons 236, which will further divided into, as a result, the barium and kryptons will be emitted. Krypton 89 and barium 57, that will be emitted, and neutrons will also be emitted. Okay. So this is what? This is a nuclear reactions. This is known as nuclear reactions. In one more example, we can say, let's suppose two elements, tritium and deuterium, will be meet, will be combined. As a result, they will emit some neutrons, as well as they will create a heavy isotopes, that is helium. That is helium. This that above example was an example of nuclear fission because a heavy isotope further divided into lightweight atoms. And the second one, tritium and deuterium, are the light isotopes of an atom. They are of lightweight. They are of light mass. Their mass is low. So they will converted into a heavy isotope of an atom, that is helium, heavy atom. So that second example is an example of nuclear fusion. But both the examples include some equations, some nuclear equations. So they are known as nuclear reactions. They are known as nuclear reaction in which the heavy isotope or light isotope, any nucleus of an atom, reacted by either by high speed atom, high speed particles, or by the combination of lightweight atoms. So these are known as the meeting, the combinations, the reaction. These all terms are related with the reactions. So they are nuclear reactions. Okay. Now I am talking about the nuclear chain reactions or chain reactions simply. So see this one, the third example, the third thing, that is your chain reactions. So what is the meaning of chain reactions? So actually this chain reaction is what? Chain reaction is actually a continuous process. It is actually related with a nuclear fusion. It is actually related with which? Yes, it is continuously related with nuclear science, that is known as chain reactions. Okay, I'm busy. Okay. So chain reaction is what actually related with the nuclear fission process. It refers to a process in which neutrons released in fission produced an additional fission. So what I want to say, chain reaction is a continuous fission process. We can say a continuous fission process, a continuous process in which a single atom further split into two different, then will further split into 2 and 2, that is 4 different, then each 4 will further split into 2 different, so continuously 4 will be emitted, in which each 4 will be continuously subdivided into 2, so 2 2 2 2, that is 8. So that kind of continuous process when happens, that kind of nuclear reaction whenever continuously happens and continuously neutrons will be emitted, so that reaction is known as chain reaction. So I just write down the standard definition of a nuclear chain reaction, or that is also a nuclear chain reaction. That a chain reaction refers to a process a chain reaction. We can say nuclear chain reaction. Both are the same term. So a chain reaction is a continue refers to a process in which the process so a chain reaction is a process in which neutrons released in fission chain reaction is a process in which neutrons released in fusion produce an additional fusion. A chain reaction is a process in which neutrons released in fission produced an additional fission in at least one further nucleus. In at least one further nucleus. This nucleus is start produces neutrons and the process repeats. Right? This process will be repeatedly repeated continuously. This is known as chain reaction. I again explaining the term. A chain reaction is a process in which neutrons released in fission process. When the fission occurs, whenever a heavy isotope like a uranium 235, when just collide with a high speed particle, that is neutrons. Okay, so this is known as fission. So what is written over here? A chain reaction is a process in which neutrons released, and as a result, barium and krypton will be emitted and neutrons will be emitted. Okay, that produce an additional fission. Now they will also generate uranium that also collide with neutrons. As a result, barium and kryptons will be emitted. So this process is continuous. This process is continuous, and this is known as our chain reaction. This is known as our chain reaction. This process is known as chain reaction. Okay? This is known as a chain reaction process. Wait to see this one. What I want to say. Now see this one. Now see this one. As we have already been studied, in case of nuclear fission, an example, I just take the same example over here. Let we have a uranium. It just collide with the neutrons, a high speed neutron. This is a reduced process, we can say. So as a result, we know that barium and kryptons will be emitted. Barium and kryptons will be emitted. Here, barium and kryptons will be emitted, and further neutrons will be emitted. Further neutrons will be emitted. It may be more number of neutrons will be emitted. You can see. Okay. In which at least one will collide with the uranium. In which at least one fission process occurs with at least one neutron. These neutrons will collide with uranium. So further, barium and kryptons will be emitted. Barium and krypton, and new neutrons will be generated. New neutrons will be Similarly, whenever this neutron will collide with the uranium, then further barium and kryptons will be generated. And further, the neutrons will be emitted. So let's see, this is a continuous process. Now they further, when strike with the uranium, let this neutrons will be strike. If this uranium when strike with uranium, when this uranium will strike with the, this neutron will strike with the uranium, and this neutron will be strike with the uranium. Then further they will further emit boron, krypton, barium, krypton, this uranium further, barium, krypton. Similarly, this barium, krypton, this for the barium, krypton, right? Similarly, for the also emit the neutrons, the number of neutrons. So you will see, you are easily see that this is a continuous process. First I start with a single, then will be double, then will be four times. So this will continuous process. So this is known as chain reaction, because as the name implies, first it will be because it is a nuclear, it include in the nuclear fission kind of process in which a heavy isotope can strike with the high speed particles, that is neutrons. New particles, new will be generated and neutrons will be emitted. So this is a that further the generated neutrons will further strike with the uranium. Further generated new neutrons and barium and krypton will be emitted. Further they will strike. So this is a continuous nuclear fission process. So whenever nuclear fission process is in continuous manner and further new generations of the neutrons and with elements, so that is known as chain reactions. So this term is known as chain reactions. Okay. Now let's see. Due to this chain reactions, a very high amount of energy is released. A very large amount of energy released. So that is very important thing. Now that's all about the chain reactions, nuclear reactions, the difference between natural and artificial radioactivity. Now we talk. Now we should see certain objective questions. Whatever we studied till. So let's see these kind of objective questions. Wait for a while. I just come with the objective questions. Yes. So now see some objective questions. Yes. So we start the objective questions. My first question is, which one is spontaneous process? Which one is spontaneous process? And your objects are, let's suppose, natural radioactivity, artificial radioactivity, both of them, or none of them. Then, as we have already been studied in natural radioactivity process and artificial radioactivity process, that which one is spontaneous? So, a spontaneous process is yes. Your answer is correct. You type the correct answer. Natural radioactivity. Radioactivity is a spontaneous process. If it is written the same kind of questions I just tagged, and instead of this, I just write down that which one is controllable process. Which one is controllable process? Which one is a controllable process? Then what should be my answer? Yes, which one is controllable? Very good. My controllable process is definitely, it is not natural radioactivity, because that is spontaneous in nature. So it is not a controllable process. It is uncontrollable process. So which one is controllable process? Definitely the artificial radioactivity, that is answer B, is a controllable process. The artificial radioactivity is a controllable process. Yes. You type artificial radioactivity. Yes, very good. That is a controllable process. Now, if I talk about that, the series of actinium and thorium related with which actinium related with artificial radioactivity or spontaneous activity, then what should be my answer? Now see this objective question. Objective question is actinium process, actinium disintegration of nucleus is related with. What should be the correct answer of this objective question? The actinium disintegration of nucleus is related with. It is a natural radioactivity process, artificial radioactivity process. It is a both natural and radioactivity, natural and artificial, or none of these. Yes. So it is a wrong answer of Hira Kumar because it is a natural radioactivity. Actinium, your thorium and uranium, both disintegration of nucleus is a natural radioactivity process. That's why answer number A is correct. Answer number A is correct. Wait, just see some more question. Yeah. So a continuous fission process can also be known as, yes, definitely. A continuous fission process we can say chain reactions. Right? Yes. Let's see this question. In the case of fusion example, we have already been talk about this term. That's why I just type here. Okay. And nuclear fission reactions becoming self-sustaining depends on electrons, neutrons, energy, or protons. So which one is the correct answer? Nuclear fission reaction becoming self-sustaining depends on electrons, neutrons. Yes, Suraj Kumar, very good. It is correct. It depends on neutrons. Because a high speed neutrons collide with. Yes. So these kind of objective questions generally comes in front of you related with this topics. So I think you understand about the today's topic, and you after the completing these objective questions, you understand that what kind of frequently asked questions in competition exams. So I Rakesh Jain from Ganyar University say thanks to you for watching the video. Thank you very much.